G'day folks. Well, it's time to start dismantling this machine. Before I do anything around here, like take the guard off, I want to get this platen assembly down as far as it can go. I don't think this has enough travel to hit those tie bar attachments, but it might get close. Apparently these are rated at about 200mm stroke, I think. Maybe more. I don't know if the 350 on this model indicates stroke length. I know they are 35 ton clamp capacity, so I'm guessing that's what the 35 is. But yeah, just looking at literature, I'm not too sure, but if I have to take these off, I will. I just want to see if putting power to these valves, looking at the hydraulic schematic, thankfully I've got the entire manual for this. What is it? Y11 and Y12 seem to tie into the clamp unit. As you can see, there's a high pressure clamp cylinder and low pressure rapid open and closed cylinders. So yeah, although actually that doesn't seem to have a port on the bottom, so I'm guessing that's the rapid cylinder and that's the clamp cylinder. Hard to tell. I'd have to go back through it and look at all the manuals. There's hours and hours of reading in this. But anyway, I want to see if I can let it down manually with power to the solenoid valves. So I've got cables connected to them, some of the spare cables that came with it. Let's see what happens. I'm going to put 24 volt DC across them. They're all 24 volt DC coils. Let's just say we've got the polarity right. Either way it should still work, because I think they're actually rated AC or DC, so it doesn't really matter. Interlock bar is out of the way. It does have a safety interlock that engages whenever the door opens. But yeah. Well, they're clicking. Nothing moving though. We have a conundrum. There's a lot of weight in that top piece, so it should be moving down if it is working. I'm guessing this is a fairly safe system. It's designed to pump itself down. Yeah. It's either that or I just start cracking lines and removing grub screws. Probably end up getting covered from head to toe in fluid, but there are other ways of getting him down. I was just hoping it'd be easy and just energise the valves, but it's pretty clear that's not going to happen. At least not with these valves. Yeah, it's not moving a millimetre. Okay, let's look at some other valves. There are more in the circuit down the bottom there. They're all tied together, especially that one there, it looks like. It's hard to tell. Y74, that's tied in, and that goes back to return too. Again, through so many other valves, I've basically got to energise all of the solenoids to just dump the entire system back to tank. I'm thinking that'll be necessary to purge fluid out of the valve body as well. It'd be good if I can just disconnect the output from the hydraulic pump, connect that up to compressed air, and just open all of the valves in both directions if applicable, and just blow most of the fluid out of the valve body and the lines. But I don't think it's going to be that easy. Not that it matters, I can still use a vacuum recovery drum and just suck it all out anyway. That's plan B. So yeah, it's interesting. At least I got the solenoids to click. Progress. Okay, well, clearly the pressure in these rams from just the weight of the platens and everything isn't enough to operate the valves. I've tried a few different valves and other things like that, and it don't move. So we'll do this the old-fashioned way. Just loosen off flanges and let oil dribble into tub, because that base is actually a drain pan. And as you can see, I've got those 1/2 inch lines off there. They're just floating in the breeze at the moment. Now, the piston that they drive, I think it's the high pressure piston, that's all the way at the top now. So when this platen goes down, it's actually going to suck air through those fittings, which is a good thing, because the platen's at the top, piston's at the top of its travel, there's nothing in the bottom. What do? It's just going to go down, draw air in through the fittings, which is good. You've got to have them off anyway, so that's good. but the other ones, well, they could get messy. The main thing I just want to avoid is oil shooting out all over the floor. Other than that, I don't really mind, because that's a drain pan and so is that. And I've started taking every second screw out so that if it does dribble and keep dribbling overnight, if it gets to a point where it reaches those holes, it'll just drain back to tank. The other fitting seems to be elevated, which is a bit difficult, but yeah. I guess that one's not as high as the others, so if I pull that return hose out, yeah, there's a flare nut on it, take that off and pull that return hose out, any major deluge of oil will just flood back into the tank through there. But either way, I'm going to get the drum of oil sucking into the shed and recover some of the oil anyway. Or at least, actually, I'll get the pump going and pump into a plastic drum, because I want to save about 100 litres or so of this oil for reuse. It's still in good condition. The last service from Battenfeld, they took it to the lab and did a test and just said, no, you don't have to replace your oil, it's still perfectly fine, which is good. They don't just periodically screw you over with an expensive oil change. At least Battenfeld just take a sample back and test it, and it's part of the service contract, and say yes or no, oil's good or oil's bad. So yeah, oil's still good. There's 100 or so litres of it in there, so I'll try and save as much as I can. Alright, well, I haven't loosened any of the major couplings yet, but I figured since I've got the suction line and discharge line off the hydraulic pump, I'll start pulling some oil out of the tank, and that's exactly what I'm set up to do here. Got my trusty oil pump, an empty drum. I've got two empty drums actually, and yeah, let's bring it up. I've already purged it. I purged the pump and let it just tick over for a bit, get any non-hydraulic oil stuff out of the system into the drain or suction drum, and now I'm just going to purge out into these and hopefully fill them up pretty effectively. This thing puts out a fair bit of oil. It's pulling some air bubbles because that's just sort of on there. So yeah, I'm getting some air bubbles. Not a big deal. Level's coming up. It's 50% speed. 70. Yeah, it doesn't like the air coming through. It's cavitating. It's still pulling that oil out pretty quick. That motor ain't even going to break a sweat. Those 600 watt motors are strong. And this is coming from the pump inlet filter. There's an in-tank filter attached to that line, so barring any minor contaminants in the hose and the pump here, this oil is pretty much filtered from the tank, so any sludge and other debris that might be in there, not an issue. Just the hose rubbing on the flange again. I'll have to trim that back. There's plenty. I don't want to overfill it, makes it hard to pour. Mind you, I'll probably use a manual drum pump to get that out. So that's pretty full. Very good. That's one container. Where's the next? Alright, let's try this. This is just a Bunnings bucket, Home Depot bucket, whatever you like to call it, Homer bucket. And that's just like a couple of RPM. Crank it up a bit. 30% power. Yeah, keep getting there. Oop, now we're getting too much air. I might put a hose clamp on that. We're getting way too much air. It's just that. The hose is just sitting on there. Oh no, someone's again going to ask what's inside this box, and essentially it's an electric scooter controller. It's a 6 MOSFET based PWM controller essentially. Pretty good. Made by Curtis. Reverse. There we go. Now it's taking a leak. And going everywhere. I'm still getting there. Unless I pulled so much out of the tank, that's it for the pickup. I know the level was low, but I wasn't expecting it to be that low. I think we're still either that or that's buggered. No, I think we are off the gauge. Wow, this thing maybe this thing really did have a low fluid level. Surprised it even worked. No, I won't say that just yet. I'll check my connections and make sure that clamp's sealed properly. I've got a feeling there's a lot more oil in there. It was low, clearly, when I looked at it, like it was barely on the gauge, but I wouldn't expect just taking 25 litres out would make it disappear. Not when this tank's rated for 125 or 135 litres. Well, after actually looking at the level gauge with the flashlight, it's way down past bottom. I guess that's it. That's about as low as the machine was on oil, about 30 litres, give or take. That's all it would have taken to cavitate the pump at that point. I knew it was low, but that's pretty low. No, well, I'll stop using the intake filter and just see if I can just dip the tube a bit further into the filler and just get some more oil. Despite the fact that the filter is there, I can guarantee this tank's probably still a third or a quarter full. There's probably another 75 litres in there. Most of the oil is for thermal dissipation. That's why you don't just have a minimal amount in a closed circuit, because it is still a closed circuit. There should be no loss apart from the occasional minor leak. But you want lots of oil to dissipate that heat through the base and everything. It's all made out of heavy steel, 1/4 inch or upwards steel plate, and basically the whole thing's a heat sink for the system. It needs heat to operate properly. It does a 30-minute warm-up cycle, just loading the pump up and just warming itself up forcibly, but it needs that mass to dissipate a lot of heat, and it also has a water to oil heat exchanger in case of overheat condition. So yeah, that's why there's usually so much oil in a hydraulic tank. It's because it's not just there for demand, but also there to help dissipate heat. And various reasons, also wear and tear on the oil. More oil means less frequent oil changes. You've got more molecules to damage, essentially. It's like a big bag full of marbles versus a couple of marbles. You keep playing marbles with a specific set, eventually you'll chip and damage them all, or fairly quickly. But if you've got a whole bag full of them, you can rotate, and it takes ages to wear them all out, or chip them all, or damage them all. Yeah, molecules, good stuff. Molecules make everything, essentially. Atoms, molecules, that sort of thing. Neutrons, electrons, calutrons, make the world go round. I wonder how much oil this tank can hold. It's filling up. I really hope there isn't a hole in the bottom of it. If not, we'll have probably the equivalent of the Exxon Valdez in my backyard by tomorrow morning. But no, it's all seam welded. Well, that's a folded U shape, the whole chassis and tank frame, but that bit there's fully seam welded in there. There's a mechanical seal there, a V-seal, something like that. Yeah, that's about it. There's a high pressure, well they're both high pressure, but I think taking that one off and the other side, this platen assembly should start dropping. I hope. If not, then I'm in trouble. I'll bet you if it does start moving, these are just going to jet fluid all the way out. So I'm going to screw that pipe back on. Yeah, that wouldn't be good. Okay, well, you know what I was saying about the Exxon Valdez? Well, it's a good thing I didn't go inside when I was going to, because, yeah, it's like, let's fully weld the tank, but let's also drill a 1/4 inch hole in the middle of the bottom. Why? The whole damn thing is sealed, but they drilled a 1/4 inch hole in the bottom. There's a centre punch firmly driven into it right now that's stopping the flow, but now I've got to clean that up. It hasn't come out that side yet, but yeah. I've got a couple of well-used oil rags that'll soak the rest of it up, but that's the first oil spill for this disassembly. I imagine there might be a few more. That usually happens. Oh well, at least I hung around. The pool would have been a lot bigger by the morning because there's still a couple of litres in there. Anyway, I guess better get the rags out. It's spreading by the second. Alright, well I made a bit more progress this afternoon. Got the recovery drum working quite well. Sucked out most of the oil from the tank to the 44 that's on the trailer using the pump. Yeah, that worked quite well. So most of the main tank is drained. That I drained and threaded a basically just drilled and tapped an M6 hole, or just drove a tap through the drain hole and tapped it out to M6 and just put a washer and rubber gasket over it, so that can actually act as a emergency drain tank. But the drum of sucking, the suck drum, works very well. There's a couple of litres in there. Whatever didn't drain onto the floor anyway. Yeah. Now I've also taken the rigid lines off the rams. They're completely decoupled. So that's good. Likewise, the locking nuts for the valve body are loose, so that can move and allow me to pull lines and things off it, especially the rigid flared lines. So yeah. And also, the platen is down. It didn't drop on its own. I had to actually force it down using the Daewoo's old jack. I just cranked it up against the top of that little guide bar, that tie bar mount, and cranked it down with considerable force. So the seals in these rams are very stiff. Compressed air wouldn't budge them, no way. You can't use them as air rams, they are stiff. They've got to be forced up and forced down. They won't simply drop on their own, which is a good safety feature, but useless for trying to do anything fun with it at the moment. I can't see it being practical to modify it considering the kind of fittings that they have on them, but I don't know, I might give it a second chance. I've got to get this guard off. That's next. Now that this is all the way down as far as it can go, it can't drop, which it wasn't going to do anyway, so I should have removed the guard before. Anyway, that's always good fun. You can see a linear potentiometer there, a nice big one. There should be 2 or 3 of those in this machine. Almost looks like a kind of encoder, but I believe these are linear potentiometers. Same with that one there. Very expensive pieces of kit. Anyway, onward. Let's get that off. That, which is the heating control. Those are thermocouple plugs. They're the plugs for the heaters. I think they're 120 volt, although it doesn't look like there's a transformer in the control cabinet. If there's anything in there, it might be a step down, but I don't know, maybe the heating bands are 240 volt. Anyway, you'll see that in the next part of the video. Thanks for watching.